Assalamualaikum warahmatullahi wabarakatuh. We are from Applied Science Faculty, which is AS120 from Group 5. We will present about the application of differentiation, which is graph of rational function. Before that, let us introduce ourselves first. My name is Nur Afiqah Nadia binti Abdul Rahman. My student number is 2020600-964. My friend.
And hi, my name is Nur Atika binti Idris. My student ID is 2020488196.
My name is Nurifa Akila binti Mafarid Shafari and my student ID is 2020882496.
My name is Nur Alia Elina binti Adam Wong and my student ID is 2020627126. So, introduction. Asymptote. Do you know what is asymptote? An asymptote is a straight line that a graph approaches without touching. There are two types of asymptote, which is vertical asymptote and horizontal asymptote. So, vertical asymptote. We need to let the denominator of a rational function equal to 0 and solve it. Then, find its analysis by approaching the value from the left and right side. So, this is the example on how to find vertical asymptote. When fx equal to x per x minus 2. So in this question, the denominator for this question is x minus 2. And we need to find the vertical asymptote by let x minus 2 equal to 0. So we will get x equal to 2. And we need to analysis of vertical asymptote by using limit, which is when x approaches to 2 from left, for this function which is x per x minus 2, we will get negative infinity. And when x approaches to 2 from right, for this function x per x minus 2, we will get positive infinity. And this is the example of the graph for vertical asymptote.
So, horizontal asymptote. To find the limit of fx when x approaches plus minus infinity, which is horizontal asymptote, we need to divide the numerator and denominator with the highest degree of x in denominator. And this is the example on how to get horizontal asymptote. First, we need to calculate the limit. X approaches plus minus infinity for function given. So, the numerator and denominator need to divide by the highest degree of x in denominator, which is x. After that, we evaluate the limit and we will get the answer is 1. The picture below shows the example of horizontal asymptote line.
Now, we look at the problem statement. Given the function fx equal to negative 1 plus x over 2x minus 1. Question A. Simplify fx in the form of px over qx, which is qx not equal to 0. Question B. Find the x-intercept and y-intercept. Question C. Find the vertical and horizontal asymptotes. Last, sketch the graph using the above information.
So, for the first question, given the function fx equal to negative 1 plus x per 2x minus 1. A. Simplify fx in the form of px per qx and qx not equal to 0. So, the first step is we need to get the same denominator. So, how to get the same denominator? We need to multiply negative 1 with denominator, which is 2x minus 1. And we will get negative 1 times 2x minus 1 plus x per 2x minus 1. And then we simplify and get negative 2x plus 1 plus x per 2x minus 1. And the final answer will be fx equal to negative x plus 1 per 2x minus 1.
Question B. Find the x-intercept and y-intercept. We need to find x-intercept first. So, how we want to find x-intercept? First, we must let fx equal to 0. As we know that fx that already simplified is negative x plus 1 over 2x minus 1. That must be equal to 0. Then we will get the answer, which is x equal to 1. So we can conclude that the x-intercept point is 1, 0. Then we need to find y-intercept. For y-intercept, we need to let x equal to 0. Then substitute the x equal to 0 into the equation. So we can get f0 equal to negative 0 plus 1 over 2, 0 minus 1. Then we will get the answer, which is y equal to negative 1. So we can conclude that y-intercept point is 0, negative 1.
Okay, for C, find the vertical and horizontal asymptotes. To find vertical asymptote, we use denominator from rotational function given and equal it to 0. Let the denominator, which is 2x minus 1, equal to 0. And we will get the answer, which is 1 over 2. But we need to prove it, whether it is true that x equal to 1 over 2 is a vertical asymptote. So in order to prove, we need to analyze this answer by use right hand side limit and left hand side limit. For right hand side limit, x will approaches 1 over 2 plus from right. As for left hand side limit, x approaches 1 over 2 minus from left. So direct substitution this equation and we will get 1 over 0 for both equation. So remember, when a number is over 0, we will get infinity and the sign is depends on the limit. The right hand side limit, x is greater than 1 over 2. So we will get positive infinity. And as for the left hand side limit, it is less than 1 over 2. So negative infinity. This proved x equal to 1 over 2 is a vertical asymptote. And next, how to find horizontal asymptote for this rotational function. So we will need to calculate the limit. So the limit, x approaches plus minus infinity for a function given, which is negative x plus 1 over 2x minus 1. We can calculate the limit plus minus infinity together, as even in a separate way, we'll also get a same answer. For horizontal asymptote, we will need to divide the numerator and the denominator with the highest degree of x in the denominator. Negative x plus 1 will divide by x, and 2x minus 1 also will divide by x. After that, we evaluate the limit and we will get the answer for horizontal asymptote, which is negative 1 over 2. Last but not least, we need to write the answer for vertical asymptote and horizontal asymptote, not just calculation.
Next, I will explain about the graphing rational function. The following steps will help to sketch the graph of a rational function, which is step 1, reduce to lowest terms and checks for any open holes in the graph. Step 2, find all of the asymptotes and draw as dashed line. Step 3, find the intercepts if there are any. And step 4, sketch the graph. And you also need to be noted that the vertical asymptotes will divide the number line into region. To solve the equation of fx equal to negative 1 plus x over 2x minus 1, you can follow the steps that I have explained earlier. Almost all rational functions will have graphs in multiple pieces like this. So we will start off with the intercepts. The y-intercepts is 0, negative 1. The x-intercept will be 1, 0. Now, we need to determine the asymptotes. So, the vertical asymptote is negative infinite. So, we've got the vertical asymptote. This means that there are now two regions of x. They are x less than 0.5 and x more than 0.5. Now, the largest exponent in the numerator and the denominator is 1. And so by the fact that there will be a horizontal asymptote at the line. Now, we just need points in each region of x. Since the y-intercepts and x-intercepts are already in the left region, we don't need to get any points there. That means that we will just need to get a point in the right region. It doesn't really matter what value of x we pick here, so we just need to keep it fairly small so it will fit into our graph. Okay, by putting all of these points, it will give the following graph that you can see in my slide. you need to be alert that the asymptotes are shown as the dashes lines.
In conclusion,
in mathematics, a rational function is any function which can be defined by a rational fraction. In example, an algebraic fraction such that both the numerator px and the denominator qx are polynomials. So now let fx equal to px over qx, where qx not equal to 0 and be written in lowest term. The coefficients of the polynomials need not to be rational numbers. They may be taken in any part of k. Lastly, on rational functions, we need to be careful that we don't use values of x that cause the denominator to be 0. That's all from us.
Thank you and Assalamualaikum warahmatullahi wabarakatuh.